Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will demonstrate how to certify a single-mode fiber optic link using a WaveTester optical power meter and a WaveSource series single-mode light source. There are 5 main steps in the process of certifying any fiber optic link. These steps are gathering link information and accessories, checking equipment and accessories for proper operation, entering link information into the certification tester if available, and setting an optical reference, also called zeroing, taking insertion loss measurements and storing test results, and then downloading stored test results to a PC and printing a certification test report. Before beginning any fiber test, the user must gather the necessary link information and accessories required to complete the test. Link information is used to help determine how much loss is acceptable for the fiber under test, otherwise known as a link budget. Optical loss measurements are compared to the link budget to determine if the fiber is good or not, which is the same as saying pass or fail. There are 5 key parameters that apply to any fiber optic test. First is the fiber type, which will be either single mode or multi-mode. In the case of multi-mode, this could be either 62.5 or 50 micron. Next is fiber length. It is important to know how much fiber is in the link under test in order to determine how much loss is acceptable for that particular length of fiber. Some OWL testers can be used to measure the end-to-end length of the fiber automatically, including the Fiber-OWL 4-bolt optical power meter. Otherwise, the user can use jacket markings, installation documents, or other length measurement methods such as OTDR. For best results, avoid estimating the fiber length whenever possible. Third is number of connections. A connection is the point where 2 fiber connectors mate together, such as in a patch panel, wall plate, or mating sleeve. Fourth is the number of splices, which can be either fusion or mechanical. For the purpose of calculating a link budget, most cabling standards do not distinguish between fusion and mechanical splices. Lastly, the user must determine what wavelengths they will test at. For multi-mode, this is 850 and or 1300 nanometers, and for single mode, this is 1310 and or 1550 nanometers. When using a micro-OWL or fiber-OWL optical power meter, these parameters can be entered directly into the device to calculate the link budget. However, if the link budget needs to be calculated manually, this is done simply by adding together the fiber loss, connection loss, and splice loss. Fiber loss is given in dB per kilometer and varies based on the fiber type and wavelength. To calculate fiber loss, multiply the fiber length in kilometers by the fiber loss. Connection loss is the number of connections multiplied by the dB loss per connection. Splice loss is the number of splices multiplied by the dB loss per splice. Most users will follow the fiber, connection, and splice loss specified in cabling standards, such as the TIA 568. It is also helpful to determine the connector type used in the link under test, which will help determine the right reference cable configuration to use. For accessories, it is highly recommended to keep at least 3 patch cables on hand, since there are 3 reference methods: 1 jumper, 2 jumper, and 3 jumper. Mating sleeves may also be required for some link configurations. Refer to OWL's video on reference methods for more information. Finally, if testing multi-mode fiber, the launch cable attached to the light source will also need to be wrapped around a mandrel according to cabling standards specifications. Refer to OWL's video on mandrels for more information. Once we've gathered our equipment and accessories, it's time to check these equipment and accessories and zero out the testers for the optical loss test. In this case, we're testing a single mode fiber, so we have our 2 single mode patch cables, one for the light source and one for the power meter. And we also have our power meter, the WaveTester, and our light source, which is called the WaveSource. Now, one thing to note about the WaveSource is that there are several models of the WaveSource. What you have to do is look at the back of the unit on the serial number sticker to make sure that you are indeed using a, or at least that you have a single mode light source in it. As you can see here, there are 2 ports. There's a multi-mode port and a single mode port. In this case, we're using the right-hand port for single mode. Now, in some models, this could be a VFL There could only be one port, one or the other ports in this. So you have to make sure that you do indeed have the right light source for your test. Now, once we've verified that we have the proper equipment and accessories, we're going to test our patch cables to make sure that they are sufficient for use. So, first thing we need to do is press the power button on both testers. Okay, as you can see, the WaveTester powers up, and you'll see that the word low appears. What this means is that the dust cap is on and that there's no light coming into the detector. On the WaveSource, you'll see that the multimode port is active by default when you first power the unit on. Since we're testing single mode, we need to switch over to the single mode port. We do that by pressing the port button. Now, as you can see, once the port button has switched over to the single mode port, we look at the indicators below the single mode port. So we see red is 1310 and green is 1550, which correspond to the color of the LED here. So again, so obviously, if the indicator LED is red, then you're putting out 1310. If it's green, then you're outputting 1550. Now, because this is single mode, we're going to be checking our patch cables at 1310. As you can see, we're at 850 here on the power meter. So we need to switch this wavelength by pressing the lambda button or the wavelength button. So we press that a couple times and we switch to 1310. Once we have our testers set, we can plug the patch cable into the two ports on the testers. Now, once we plug in, our target value is minus 10 dBm. Minus 10 dBm is where our single mode light sources are calibrated at through a single mode patch cable. In this case, we have a reading of very close to minus 10. It's minus 9.96, minus 9.7. You can't get much closer than this. So what this means is that this patch cable is okay to use for our test. So once we've verified that, we simply disconnect it from the testers. And then we put the dust caps back on. And we set this patch cable aside for later use. We won't need it for a while yet. So we'll just set it aside. Now we take the second patch cable, the patch cable that we will be using to zero out our light source. We plug that in as well. Okay, now as you can see, this is even higher level, minus 9.5. Okay, this patch cable is also sufficient to use. Really what you need to concern yourself with is whether or not the patch cable is exceeding minus 11 dBm. At that point, it's best to consider replacing the patch cable. So once we've figured out that our reference cable is okay to use, we can actually zero out the power meter and light source, which is, in other words, you can zero out your equipment for the optical loss measurement. Now, specifically with the WaveTester and the WaveSource together, there is a special feature called auto mode that we can use. And auto mode allows us to set references and store 2 wavelengths of information at a time. So this is easily done by pressing and holding the lambda auto button here. So you press and hold that. You'll see that there's a wavelength and then auto, wavelength auto. What this means is that the WaveTester is now in auto mode and it's scanning for incoming signals. The reason it says auto here is because it is not receiving an auto testing signal yet. On the light source, you'll see that the wavelength button has a second function called auto here. And what we need to do to set auto mode on the WaveSource is press and hold this auto button until the indicator LED up here begins flashing. And at that point, immediately remove your finger. So I'll demonstrate that here. Once the WaveSource is in auto mode, you'll see that the indicator LED will begin alternating between the green and the red color, which means that it's alternating between 1310 and 1550. As you can see on the power meter, that the WaveTester is also switching at the same time as the light source is switching. What we've done now is ensure that we are indeed in auto mode. Once we have reference levels for both of these, both wavelengths, we simply press and hold the 0 button here. Okay, now you can see that for both wavelengths, we're reading very close to -0 or 0.00, which means that we've zeroed out our equipment. You'll also notice that the indicator, the units indicator switched to dB. dB is loss mode. That's what you're using to actually measure the loss of your cable. So now that we've zeroed out our equipment and made sure that our patch cables and testers are good to use, it's time to take the units to opposite ends of the link and start our optical loss measurements. Once we've checked our equipment for proper operation and zeroed out the testers, it's time to take each of the testers to opposite ends of the fiber link that we're going to test today. Now, as you can see, we'll need to take our WaveSource with its patch cable to one side of the test here. And as you can see, you'll get a reading. It'll start saying auto again here because, again, the WaveTester is not receiving an auto testing signal. Once we connect in, we will get that signal back. But for now, we don't have any signal there, and that's also why we're reading a much lower power level than normal. What we're actually doing is reading ambient room light at this point. So we take the WaveTester to its side of the link, and we connect its patch cable in to the detector port here. Okay. Now, once we've done that, we simply take the patch cables and we plug them into both ends of our link. Now I've got this box here that simulates a fiber link, and if you can use your imagination, picture side A being one closet with a 6-port patch panel in it, and side B being in another closet with another 6-port patch panel. Okay, and these ports are numbered 1 through 6, as you can see here. So the first thing that we need to do is connect into port number 1. That's usually where we start here. So we'll connect both of our cables into port number 1. And then we wait for the auto testing signals to take effect. What you need to do is watch the WaveTester here. Make sure it goes through a couple cycles of the wavelengths. Once you've done that, now you can press the save button here to store the readings. Now what's going to happen is that because we're taking two measurements, we're in auto mode, we're going to take a 1310 measurement and a 1550 measurement simultaneously. So when I press the save button here, you'll notice that the fiber number will increment by 2. As you can see, there was no data stored, so it stored readings 1 and 2 in the meter here. So, and as you can see, there's a little floppy disk icon. That indicates that there is now data stored in the meter. What I'm going to do is I'm going to speed up the process and store the rest of the readings here. And finally, we store readings for port number 6 here. Now, as you can see, it said 12 there, which means that we stored 6 fibers with 2 wavelengths each. So once we've stored all our readings, it's time to take the WaveTester to a PC and download the test results to produce a certification report. Once data has been stored in the optical power meter, test results can be downloaded to a PC to produce a certification test report. First, install the USB driver and OWL reporter software from the supplied CD or a USB flash drive. Connect the power meter to the PC using the supplied USB cable. And then power on the power meter. Then start the OWL reporter program. The program shortcut can be found in the Start menu. When the software has started, the screen will initially say no data loaded as shown here. Download the test results to the PC by pressing either the download menu option or the download button. While downloading, the status bar will say searching for OWL device. Specific to the WaveTester, once test results have downloaded to the PC, OWL Reporter launches a link wizard. Users will be prompted to enter link information into dialog boxes, starting with the cabling standard. Click the arrow in the drop-down menu to show a list of cabling standards, then click on the standard to select. Once the chosen standard is selected, click Next to continue. Click the drop-down arrow to show a list of fiber types, then click on the appropriate fiber type. Then click Next to continue. Enter the fiber length by selecting the appropriate measurement units, then typing the length number. Click Next to continue. Enter the number of interconnections and splices for the fiber under test. A connection is simply a patch panel, wall plate, or other mating sleeve. Likewise, count the number of total splices in the link under test. Most cabling standards do not distinguish between fusion and mechanical splices. Click the New Organization button, then enter the organization name and telephone number. Once the organization name appears in the drop-down box, click Next to continue. Enter the date of test. By default, the current date is displayed. However, if the date of test is different, use the drop-down menu to change the date. Finally, enter a descriptive name for the link under test. Once the test results have successfully been downloaded, the data will appear in the OWL Reporter screen. The test results can be viewed in two different formats. This view is called Circuit Detail View. It shows detailed information about a single fiber run. The other view is called Circuit Summary View. Circuit Summary View shows basic information about a group of related fiber runs. Certain buttons become active when Summary View is selected. Pass-Fail, Overhead, which shows how close the test is to its fail point, or Optical Loss. Toggle between Summary and Detail View by pressing this arrow button. Test results can be printed from the File menu or Printer button. The printout will show test results based on the currently selected view. The reports are formatted to look like the OWL Reporter screen. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos, or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.